Welcome back to my YouTube channel. A happy new year to everyone. I'm so happy to be back this year, and I'm thankful to you all for riding with me throughout 2024. And I really can't wait for everything that we're going to be achieving together this year, right? If this is your first time on my YouTube channel, Oluwatosin Serah. I'm a first contract developer. I'm a technical writer. I'm basically just an explorer, right? I explore, I build, and yes, and this is one of the things that building, right? Building this channel to help people, right? Build on Starknet, right? And yes, you can always feel free to watch the previous videos, right? And let's get started. In today's video, we're going to be solving the Starknet challenge in the Starkling challenges. So this video is going to be the last episode or the last video on Starkling challenges. I don't know if you're excited, but I am excited, right? Okay, so we're going to be going through Starknet from part one to part five. And I think this is beginner friendly. The way I can see the structure from here is beginner friendly. So if you're a beginner, you can be sure to stick through the video as I'm going to like do justice to explaining everything that is happening. So without further ado, let's just get right into the video. Okay, so the part one of the challenge says that Starkling, Joe is writing a really simple contract. The contract shows that he's the owner of the contract. However, his contract is not working. What he missing? So we're supposed to like find out what Joe is missing out in his contract, right? So the we have the interface. So when you want to write an interface, when you're building on Starknet, you use the attribute Starknet interface. So this shows that this is an interface with the traits, and then you use the contract, and then the contract name. I is interface, and the contract name is Joe's contract. So we have the interface right here with just one function, get owner, which returns um, which returns fail 252, right? It takes in the contract state, reading the contract state, and return fail 252. And then we have the contract itself with the storage. Um, Recall that when you want to uh, write a state, you want to write a state in Starknet, on Starknet, your Starknet contract, you make use of the storage attribute with the storage struct. So your state variables goes into the storage struct. And then we have the implementation. The implementation is going to be the implementation of this trait, the function in the interface. So right here we only have one function, which is the get owner function. And then you can see the in the implementation, we have, I think I explained a lot more about implementation traits in uh, the I think previous videos, so you can always go back to check the videos, right? So we have the function where the logic is happening for the implementation get owner, which takes in is basically reading from the state, and then it returns the fail 252. And then we have the test. This test is not really something we are interested in, but always like gives us like an hint to solving the challenge. But before we even check the, let's see, would see, maybe we need to check the test. But what we basically need to do is Joe wants to write a contract that shows that he's the owner of the contract, right? So what we need to do is first of all set the storage. Set the storage. How can you know when you're writing a contract? How can you know that the owner of the contract is this person? So the best way for you to know is when you're deploying the contract, as long as, like, as soon as you're deploying the contract, there should be a function that is setting the state variable of who is the contract owner, right? So what we're going to do right here is to just have like an owner variable that we are going to be using to set the contract owner to be Joe. So we have the owner variable, and the owner variable from here, normally we are supposed to have um, a unique keyword, such as that of contract address, because it's unique. No two contract addresses are the same, right? So but with the design of this contract, you can see that it's returning fail 252. So that means you have to like make use of fail 252 right here. So owner is going to be represented in fail 252, and then we need to create a constructor which sets the owner of the contract. Let's create the constructor attribute, right? And then the constructor function, constructor the constructor is going to, we need to write to the state. So ref self contract state, taking the contract state, right? And then what we need to do right here is we want to set the owner of the variable straight away. So once the contract is being deployed, this contract knows that this is the person that owns this contract. Now we are going to write to the state self. So we call the storage. We're writing to the owner's variable, and then we write to it that, okay, see, the person who owns this contract is Joe. So that's what we want to do. We're just going to add code it. We're just going to add code it. Let's edit this get owner. This get owner, we just basically need to read from the state. So we do self dot owner dot read. That's how we read from the states. Yeah. And I think that's all. So let's test our, oops, we have something went wrong with your code. Append entry point not found. Okay, so we didn't make the function, so we need to add the ABI embed v0 version 0 above the implementation. So let's do that. ABI embed underscore v0. Yes. So this makes your function public. So we basically use this ABI embed v zero to like make the function external, right? Is so it makes this get owner function callable from outside of the contract. Without this embed ABI embed v0 version 0, no, like no one would be able to call this function to check who owns the contract. So let's test, and I think yeah, that works well. Let's move to the next tax. The next tax, uh, so Joe's contract in the last exercise shows that Joe is the owner of the contract. He thanks you for helping him out. You're welcome. Jill says that Jill says that contract should allow setting the owner when contract is deployed. Okay, he helped Jill rewrite the contract with a storage and a constructor. There is contract address, you see now, it's going to be unique right here. There is contract address type which should be used for wallet addresses. So on Starknet, both your wallet address and then your contract address, both are contract address. They are contract address, because of the account abstraction, right? So they are both contract address. So when you want to like you want to check for um the caller of a function, right? You use the contract address type. You use the same for if you're trying to check for the smart contract address, you use the contract address type. And even if you want to like check for the maybe somebody that is calling the function using a wallet such as agent, you still use the contract address type. So now let's check our contract. So and then when you need to explicitly like type this out for you to be able to use the contract address type. So you use Starknet contract address. So your contract, the compiler will be aware that you want to make use of the contract address type, right? So we have the storage. Our to do right here is to add contract owner storage with contract address type. So add it. Let's add it. So we're going to do contract owner, and then the contract owner is of contract address. We are done with that to do. Now we have the constructor which takes in the owner, right? So to do, write owner to contract storage. So what we're going to do right here is to write contract owner. We want to write to the contract owner to tell the contract, see, this person that we want to say right here is going to be the contract owner of this contract. Yes, and you have to know that. So we are setting that uh dot contract owner dot write. We are writing the owner that we're passing in. Yeah, that's basically that. And then we have, let's check the implementation function. Get owner returns, we want to get the owner of the contract, so it should return the contract address. So let's read from the storage. Are you bringing me down here? uh let's read from the storage. So we basically do self dot contract owner dot read, as simple as ABC. So let's test the contract. And yes, our code compiled successfully. Let's move to the next task. The next task is it says Joe liked Jill's work very much. He really likes how useful storage can be. Now, they decided to write a contract to track the number of exercises they complete successfully. Jill says they can use the owner code and allow allow only the owner to update the contract. Right here, they want to allow only they want the owner of the contract that is being set to be able to update the contract. So they agreed on it. Can you help them write this contract? Of course, why not? So right here we have a contract called progress tracker, and then we have the interface for it, which has three um, functions: set progress, get contract owner. It takes in the set progress takes in the user, it takes in the address of the user, new progress. um Get progress takes in the contract address, so it will return the progress of the user, right? And then get owner only just returns the owner of the contract. So you can see something new here. We have use Starknet get caller address. So this is required to for you to be able to um um get the caller address, the person calling a function. So it's similar to sender in Solidity. So to be able to like track the person who, either it's a person or a contract kind of, that is triggering that function, that particular function. So the get caller address to be able to help track that. You see how we'll make use of it in the contract. So the storage, we have the storage, um, which has the variable contract owner of type contract address. So to do set types for legacy map. So legacy map is just like mapping, right? Mapping, which is like dictionary. It helps us like keep track of when you're say you're looking for a word, you just pass in the key and you find the word, right? So that's how legacy map works as well, just like mapping. So for the legacy map, we are going to pass in contract address, right? Contract address is going to be the unique key, the key, and then user is going to user, which is of U16, is going to be the value, right? So to check the progress, so we call contract address and then U16. That should be U U16. Okay. So the contractor have been written to do right here. So let's see the set progress function. We need to set the progress, and we need to make sure that, remember, only the owner of the contract should be able to set progress. No other person outside can should be able to set the progress. So that's what we need to do. So to do assert owner is calling. Okay, so we need to like make use. So let's do let we are creating a variable caller. So we want to like first get the person who is calling this function. Let caller is equals to get caller address, and then to do set new progress for user. So now since we have gotten the the color, we now, no, okay, since we have gotten the color, we need to assert that the color is actually the owner. Sorry. So assert that color is the same person as, so we need to read the state to get the real owner. um contract owner dot read. So we need to assert that the person that is calling this function is the contract owner. If the person is not the owner, this is going to panic. Caller owner is not owner. Now, once that check is done, if the person calling this function is actually the owner, it should be able to progress. The caller should be able to progress. But if not, is the function is going to like fail. Now let's set the new progress for user. Call self dot progress dot write. We want to write. So the first thing we have is contract address, and then the contract address right here, the variable holding it is user. So we need to pass in user, and then the new progress that we want to set, new progress, and that's all for that. That's all. That's all. So we also need to get the progress. We need to get the progress. That's very straightforward. Self dot progress dot read. And then when you want to read the progress of a particular user, you have to pass in the unique keyword, which is user, right? So we should be done with the implementation. Yes, and that compiles successfully. Let's move to the next task. So the next task says Liz, a friend of Jill, wants to manage inventory for her store on chain. This is a bit challenging for Joe and Jill. Liz prepared an outline for how contract should work. Can you help Jill and Joe to write this? Okay, so now we have the list inventory contract, and then with the interface we have four functions: add stock, purchase, get stock, get owner. It's kind of straightforward. So to add stock, right, it's going to take in the product to add, and then the new stock. So let's just go forward to the contract. So for the storage, we have contract owner, and then to do add storage inventory that maps product fell 252 to quantity U232. So they have been specific right here. So what we're going to do is let's name it inventory, and then it's going to be legacy map, right? Legacy map, and then it's going to be mapping the product. So product is fell 252, as you can see right here, fell 252, and then it's going to be mapping it to the stock, yes, to the stock quantity. and the stock quantity should be represented in U32. 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 Yes. Now, for the act stock, for the act stock implementation to do take takes product and new stock, add new stock to stock inventory. Only owner can call this. Okay, we already have our constructor. The constructor has already been set to owner. One thing you should note that the first check you always do when you want to add a restriction to your function is to like make checks for those restrictions before you go ahead to update the function to write to the state of that particular contract. Now the first thing that we're going to do is this last task that says only owner should be able to call this. So what we are going to do is to um let caller equals to get caller address. Now we need to assert that caller is equals to the owner of the contract dot contract owner dot read. If not, caller not owner. Caller not owner. Okay, so now we need to now like take products, new stock, okay, to update. So we need to update the parameters, right? So product, remember the product is of fel 252 type, fel 252, and then the quantity, was this a quantity? Oh, new stock. So we're going to use new stock. The quantity of the new stock is going to be in U32, uh, bit size U32. So now let's update. We have done our checks. Now let's add the new stock to the existing stock that we already have. Let me make it just here. So we're going to do let the current stock. Let's read the current stock. Let the current stock equals, we want to check for the current stock, inventory. So this is what we are calling the map inventory, and then the inventory takes the key is the product, right? So we're going to pass in the key. We want to check the the current stock of that particular product, if available or not. Dot read, I forgot dot read. Yeah, am I putting space right here? Okay, now so let's now update. We're now going to do self dot inventory interface, not interface, self dot inventory dot write now that particular product that we want to add, and then we are going to now do, now we want to like take in the quantity of that particular the quantity of the new stock that we want to the product we want to add. So we are going to do current stock plus the new stock, this new stock, and that's all. That's all for the add stock function. So let's look at the purchase. The purchase takes product and the quantity, subtract quantity from stock inventory. So once somebody is purchasing a product, right, is leaving the stock. So we need to like subtract to know the amount that is left in stock. So anybody should be able to call this. I mean, anybody should be able to come buy a particular stock, a particular product in inventory. So what we are going to do is let's take in the product first. Product felt 252, quantity is going to be U32, right? So now there's no restrictions. Um, Let me start from here. So we are going to check the current stock as usual. Let current stock equals to self dot inventory dot read that product that they want to purchase, right? And then we need to now like update the inventory of that particular product. And so um, we need to, okay, we are going to update, right? So one thing we also need to like take note of, right? Um, we want to ensure that that stock is actually available, right? How do we check that that stock is available? There is no restriction, but we need to also check that the stock a user wants to purchase is actually available. So let's make some assertions. Assert that um, the current stock, right? You know, we're reading from the current stock is greater or equal to the quantity, this quantity that the user wants to purchase, right? If not, if this doesn't pass, let the user know that it is insufficient stock or product, whatever you choose to use, right? So now we can now update. Are you following? Thank you. So self dot inventory, now we need to like update right to the state for that particular product. um Taking the products, the product is the key, don't forget. And then we're going to do current stock, the current stock minus the quantity that this user wants to buy. Quantity, and that is all. That is all. Okay, we have another to do. We want to get stock. We want to get stock. And when we want to get stock, we need to um, have the product, pass in the product. So, and then product is in file 252. File 252. And then it will return the quantity of that particular product in stock, right? So do self dot inventory dot read products. Yes, and that is all. No, that is all. So let's test our function. Great, 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 great. Let's move to the next task. So the next task, which happens to be the last task, says address all the to-dos to make the tests pass. Okay, let's check this. So we have the contract interface, I contract A, which have a function to set value, takes in the value and returns a bool, gets and then get value. So let's check the contract A. Okay, so one thing is, once you see something like dispatcher or something, you will know that there's going to be, or there's a cross communication that's going to be happening, like from, maybe a contract needs to read from another contract, something like that. Yes, so that's when we get to use dispatcher. So we have, from the contract A, we have um the storage of contract A. It has contract B contract address. Whereas this contract the contract address of contract B, and then we have the value. Okay, so the constructor takes in contract address contract B, okay, passing the contract address of the contract B on deployment. Okay, and then we have the implementation, set value get value. Set value is going to be the to do, right? Takes in the value, returns bool. Check if contract B is enabled. If it is, set the value and return true, otherwise return false. Okay, so this challenge is like contract interoperability, like I said, like cross interaction in Starknet, where contract A, which is this, needs to interact with contract B. Right, as you can see, it's taking in the contract address of B, and you want to check if contract B is enabled, like, right, and then, so before we can perform certain operations, like if it is, we set the value, return true, otherwise it's going to return false. We set it to return false, right? So what we are going to is going to challenge is going to be achieving, right, is contract A, right, can only set a value if contract B is enabled. Contract B has, so from that you can infer that contract B has a an enabled or disabled state. So let's go to contract B. So this is contract B. As you can see, this is enabled. This is enabled. Like I said, this is enabled. So, and it's of bool type, right? Enable, disable is enabled. You check whether it's enabled or not, right? So, the the test is going to also this text interaction, right? Deploy contract B, deploy contract A. Okay, well, we have another to do here. To do interact with contract B to make test pass. Could not set value. Value was not set. Contract B is not enabled. Okay. All right. All right. Uh so let's solve the to-dos. We have two to-dos. Let's solve the to-do and let's see if we can make the test pass. So um we need to first in contract A set the function, the set value function, right? So we need to check contract B state. So how do we check the contract B state? Let me come here. So we are going to first let's we want to set the contract. Okay, so we are going to create a dispatcher to interact with contract B. Dispatcher is going to be the one in doing the interaction for us. So let's do let contract B um let contract B equals I I contract dispatcher, I contract B dispatcher, right? Now we are going to do contract address, contract address, contract B is of contract address, right? So contract address is self dot contract B. So we are making interaction, we want to make interaction with contract B dot read. Now we have created the dispatcher for the interaction, right? So let's now check if contract B is enabled. So we're going to use the control flow. If control B dot control contract B dot okay is enabled, if contract B dot is enabled, we set the value and return true. So we're going to do self dot value dot write the value, and then we set it to true. Else, if it is disabled, that means if it's not true, if it's disabled, we return false without setting the value. So just return false. Okay, and that should be it. So for this, the second to do, interact with contract B to make the test pass. Okay, so to make the test pass, this test, see, is asserting that set value is equals to true. So that means we have to like make it true. We have to make it true. Is enabled is true, contract is not enabled. So interact with contract B to make the test pass. So let's do how do we enable? Okay, yeah, there's a function for enable. So we do contract B dot enable. Okay, so let's run the test first. Great, great, great. Our code compiles successfully. So basically, in the contract A, in this contract A set value, we created a dispatcher right, to be able to interact with contract B using its address stored in contract A. This is the address. If you check the story, this is the address that was controlled with the contract A, and then we check if contract B is enabled right, using the enable function in the contract B. So if enabled, we write the value, the new value, and return true. If it's not, we return false without modifying the value, right? So um that is all. So with this challenge, so it just like shows how um in cross interaction, right? Cross interactions like happen, one of the use cases, right? It happens in, you can do cross interactions in Starknet. And this has like brought us to the end of the Starkling challenge. Let's go to the next. Congratulations, we are now a Cairo rock star. Thank you for completing the Starkling challenges with me, right? If you got questions, if this video have been very helpful for you, make sure you share this video to people that you know that want to get started in their Cairo journey. It's going to be helpful to them. And if you know maybe somebody that is stuck with a particular challenge, share this with them for it to be helpful, right? And also make sure you leave a feedback, a comment in the comment section, sharing how this video has been of help to you. And you can also like give me a shout out on Twitter. I'll be open to retweeting and also sharing. Thank you so much for watching, and I'll look forward to seeing you in my next video. Thank you and